All right, so the last part of this slope deflection example is to do the statics from the moments that we calculated. And so we calculated these moments here. So for member AB, I would recommend redrawing the blown up structure, member AB. And here, this negative 5.56 meant that it is not going clockwise in that sense that we had. So here, this negative 5.556 means this is 5.556 kilonewton meters right here. That negative means that it's going this direction, right? As opposed to clockwise, it's going counterclockwise. And here for member BA, because it's positive, that means this moment is also, it's clockwise. It's still clockwise, 26.389. So I highly recommend just drawing the moments right onto the beam structure itself. And the loading. Don't forget the loading. You have no idea how many times people forget the loading, right? And here, so here's my structure. I have a shear on the cut over here, VA, and a shear over here. I'll call this VB on the left side of the joint. Okay, the left side of that joint. So this is member AB, and again, this is member AB. Boo 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 boo. A little bubble right there, right? And the length of this member is I believe it was 10 meters. All right. And here for member BC, which was much longer, here I had a 1 kilonewton per meter load, 1 kilonewton per meter. And again, the end moments, MBC is negative, and initially we had drawn it clockwise, which would have been like this. Now it's counterclockwise like this, of 26.389 kilonewton meters right here. And then here I have a positive 36.805 on that side, which meant it is still clockwise, 36.805. Bam. And then here the shear on this side, I'm just going to initially draw it like this, VBR. And on this side, it will be the shear at C right here. And now using basic statics, so for member AB, basic statics, I can determine VA and VBL, right? And so let's see here. Let's use some statics here. So if I take member AB and I sum the moments about point A equal to 0, right here, and this will just be minus VBL times 10 meters minus 26.389 kilonewton meters minus 10 kilonewtons times 5 meters plus 5.556 kilonewton meters equal to 0. And some of you are probably saying, why is he writing kilonewton meter each time? You know, it's all the same. Don't be homeless. Just write them in. That way you don't mess up, right? And so here, VBL is equal to, just, bland, plug and chug, minus 7.083 kilonewtons right here. And hopefully that number's right? I'd rather get my units right and be a little bit off, I guess, in the numbers. But anyway, that's, it's like designer choice. It's your preference. All right. So here, and then once I have that, I just sum forces in the y equal to 0, positive this way. And I'd have VA minus 10 kilonewtons minus VBL equal to 0. And notice I didn't let this negative sign influence the way I wrote this equation. Now, this equation is based purely on the drawing right here. And so if I plug and chug now, I would have VA minus 10 kilonewtons minus 7.083 kilonewtons equal to 0. And this VA is equal to 2.917 kilonewtons. Okay, right there. Bam. And then doing the same thing for member BC. Oh, don't judge me on this line right here. But for member BC, again, doing the statics for member BC, you just, some moments about point B, and what you'll get, hopefully I don't have to show you this again, but here you would get that VC is equal to minus 10.521 kilonewtons. And hopefully I'm right. Maybe some of you are checking. It's like YouTube homework. And then some forces in the Y after you find VC. And I would get VBR on the right side is equal to 9.479 kilonewtons. And now I'm ready to draw the shear and moment diagrams here. And look at this drawing right here. VA, this is 2.917. This is 2.917. Oh, you know what? It's all good. Let's go and redraw it right here. So here, if I draw the shear moment diagrams for this, let's see if I can get a little bit of drawing over here. So here, use a straight edge, and this would be like this, and right here, and I would have this right here. And what it means, if I have this, this would be my shear diagram in kilonewtons. I would go up 2.917 kilonewtons, go all the way across until I hit my 10 kilonewton concentrated load, and then go straight down 10, which would get me to 7.083, hopefully, and I think it does. Yay. Okay, negative 7.083, and then bam, there's my shear diagram for member AB. And then here's my shear diagram. That's nice right here. And then I could draw the moment diagram here, the moment diagram. So bam, let me draw the moment diagram. That looks kind of straight. Moment diagram. A line using a straight edge. Here's a moment. Units of kilonewton meter for member AB. And again, I know that I have this right here, this 5.556 kilonewton meter. I'm drawing my moments on the compression side, right? So those of you in Europe, don't judge me, right? So here, 5.556 kilonewton meter right here. Bam. Okay. So this is negative 5.556 kilonewton meters right here. And then I have, let me keep it in blue, the area here, this area right here is going to be my change in moment. So 2.917 times 5, whatever this distance, I believe is 5 meters. And so that change in moment is some number, and I calculated it already, and hopefully this calculation is right, but it takes me up here to 9.029. This number is 9.029, and my moment diagram looks like this. Whoa. It looks like bam. All right, like that. And this is that minus 5.556. And then here I have this area right here. This will be 7.083 times 5 meters as well, which is something near 35. And minus 9 gives me something near 26, which in this case is minus 26, which is way down here somewhere. So here is minus 26.386 kilonewton meters, and this is my moment diagram, and like that. Okay, and so that's your moment diagram. That looks good. Oh, make it pretty. Bam. What up? All right, so that feels good, right? Got a moment diagram, and then you do the same for the other, right? And here, I'll pause the video so you don't have to fast forward and waste your time, and I'll just show it. See ya. All right, so here's my shear and moment diagram for member BC. Again, linear here with the 1 kilonewton per meter slope, and that's why the 0 occurs at 9.479 meters. And then I can calculate the area here, determine the change in moment, and here I get the peak moment, positive moment of 18.539. This is moments all in kilonewton meters right here, and then this negative 36.805 to finish it off right here. So here's the shear moment diagram, and the answer, I guess, to this question started a long time ago, about 30 minutes ago. Anyways, hope you enjoy, and hopefully it was enlightening. Let me know if you have any questions. See ya.